Welcome to the first part of the next lesson in this module, which begins our overview of the Java object-oriented programming language. Java was originally created by James Gosling and his colleagues at Sun Microsystems in the early 1990s. Dozens of object-oriented programming languages have been developed over the past 6 decades. Although these languages differ in various ways, they all support key object-oriented programming concepts, such as abstraction, inheritance, and polymorphism. After completing this part of the lesson, you'll know what these concepts generally mean in the context of object-oriented programming, understand specifically how the concept of abstraction relates to the Java programming language, recognize the benefits abstraction provides developers of Java apps and Android, and be able to identify Java features that implement various data and control abstractions, such as Java's conditional statements, loops, classes, and interfaces. Neither parts of this lesson examine Java code examples in detail, since our goal here is just to provide the big picture of object-oriented concepts and Java features, rather than give a detailed explanation of these topics, which is the focus of the rest of this MOOC. Therefore, feel free to race through this material quickly if you don't need a high-level overview of object-oriented programming concepts now, and then return later and rewatch this lesson after completing the remaining modules on the Java programming language. However, if you're interested in deepening your understanding of these object-oriented programming concepts at this point, we highly recommend that you read the material at the URLs listed on the slides to learn more about each topic we discuss. Java is an object-oriented programming language, which means that apps written in Java are organized in terms of structural elements, such as groups of classes, interfaces, and packages whose arrangements are guided by design patterns. These structural elements are used to create, access, and manipulate objects, which are instances of classes that perform certain operations and interact with other objects in an app. An object in Java resides in a memory location of a computer. It consists of state, represented via Java data fields, and behavior, represented via Java methods. Objects often correspond to entities found in the real world. For example, an online banking app might have objects like accounts. An account state keeps track of the account balance and whether overdraft protection is enabled. Likewise, its methods implement behaviors involving deposits, withdrawals, and checking the current balance of an account. In contrast, non-object-oriented programming languages, such as procedural languages like C, Ada, or Fortran, organize apps in terms of functional elements, such as actions and logic. Naturally, object-oriented programs written in Java also perform actions and contain logic. However, these functional elements don't constitute the main focus of the way programs are structured and designed in Java. Instead, Java supports key concepts found in all object-oriented programming languages, including various data and control abstractions, such as classes and loops. These abstractions enhance the modularity and clarity of object-oriented app software by emphasizing important interfaces and operations and objects, and shielding app developers from unimportant implementation details that are likely to change over time. Other key object-oriented concepts supported by Java include inheritance, which enhances reusability by enabling a class to receive and extend methods and fields defined by its parent class, and polymorphism, which enhances extensibility by enabling transparent customization of existing class behavior to meet new requirements. Many popular programming languages implementing these object-oriented concepts are in widespread use today, particularly Java, C++, C#, and Python. Therefore, once you understand the features of Java covered in this MOOC, you should be able to learn other object-oriented programming languages quickly and easily. If you're already familiar with Java, however, you may be bored by some portions of this MOOC. In this case, feel free to move through this material quickly so you can start on the next MOOC in the specialization. However, make sure you really understand how to program Java for Android, since examples and assignments appearing later in this specialization assume you possess this knowledge. The first object-oriented concept supported by Java that we cover in this lesson is abstraction, which is an essential part of all object-oriented programming languages. Abstraction helps developers master the complexities of writing apps by emphasizing what's important and de-emphasizing what's unimportant at a particular level of detail. In particular, abstraction helps developers focus on what their apps are doing to meet the requirements rather than being distracted by lower-level implementation details of how their apps work in a given operating environment. Java supports many object-oriented abstractions that we cover throughout this MOOC. For example, it supports various data abstractions, such as classes and interfaces, which cleanly separate key abstract properties of a data type, such as its application programming interface, or API, from concrete implementation details, such as the use of a particular algorithm or data structure. This separation of concerns avoids breaking app code that uses the API when implementation details are modified or optimized. Java also supports a number of control abstractions, such as if statements and for loops, which determine the order in which individual statements or method calls are evaluated or run. We'll now summarize various examples of data and control abstractions supported by Java. Java supports data abstraction via the concept of an abstract data type, or ADT, which defines a set of data values and a set of operations on these values. For example, the Java integer class is an example of an ADT that contains a value, such as the number 42, together with operations on the value, such as methods that create an integer object from a primitive int value and vice versa, as well as methods that compare two integers for equality. At the heart of an object-oriented language's support for data abstraction is encapsulation, which hides an ADT's internal representation to ensure apps using the ADT can only access its public operations and can't access any of its implementation details that may change over time. Java supports ADTs via its class feature, which defines a blueprint for creating objects. A class provides both fields, which are used to store the state of an object, and methods, which are used to implement the behaviors of an object. For example, the Java string class contains fields that store a sequence of characters and the length of the sequence, along with methods that examine individual characters of the sequence, compare strings, search strings, extract substrings, and create copies of a string. In Java, all objects created from the same class share the same methods, but each object may store different data values in its fields. Another form of data abstraction supported by Java is the interface, which defines a contract specifying methods that classes implementing the interface must provide. A Java interface provides a subset of the features provided by a Java class. For example, an interface in Android cannot contain method implementations, only method signatures, which include the method name and any parameters that indicate what values can be passed to a method when it's invoked at runtime. A Java interface can't be instantiated, but instead must be implemented by a class, which defines the interface's methods, along with any fields needed to implement these methods. For example, the Java comparable interface defines the compareTo method that compares an object to another object to determine their relative order. This interface is implemented by classes like integer and string that define a natural order of their instances. Classes and interfaces can be grouped together into packages, which provide a namespace for organizing Java code in a logical manner. For example, the java.lang package contains classes that are fundamental to the design of the Java programming language. The Java util package contains a collection of common reusable ADTs, such as ArrayList, HashMap, and Vector. And the Java I/O package contains a group of classes that perform system input and output via data streams, serialization, and the file system. Organizing classes and interfaces into packages makes it easier to manage large software projects with many team members by avoiding collisions between classes and interfaces that have the same common name, such as point, shape, or map. In addition to being grouped into packages, classes and interfaces can also be parameterized via the Java generics feature, which enables the passing of ADTs as parameters to the definition of classes, interfaces, and methods. For example, the vector class in the Java util package can be parameterized so that its methods operate on a particular ADT element, such as an integer or employee. Generics offer several benefits to Java programmers. For example, they eliminate the duplication of code by adhering to the don't repeat yourself principle, which states that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Generics also ensure compiler type safety when operating on different types of ADTs. For example, a vector of integers will not accept a value of type double. Likewise, a vector of doubles will not accept the value of type integer. The Java Collections framework uses generic classes and interfaces to implement common type-safe reusable ADT collections, such as ArrayList, Vector, and HashMap. which in turn can be parameterized by other ADTs, such as an array list of integers, a vector of doubles, or a hash map of employees. The Java garbage collector supports yet another form of data abstraction. Garbage collection is a memory management mechanism that automatically reclaims and recycles objects not currently in use by an app. Java's garbage collector makes it easier to write apps by alleviating many tedious and error-prone aspects of releasing dynamically allocated memory in languages like C that lack garbage collection. For example, it abstracts the steps associated with manually keeping track of how long each object is used in an app, so the object's memory can be released when it's no longer needed. Not all object-oriented languages support garbage collection, but it's an essential feature of Java. In addition to the data abstraction mechanisms we just covered, Java supports various control abstractions, which determine the order in which individual statements or method calls are evaluated or run. A fundamental type of control abstraction is the conditional statement, which can be used to selectively alter the flow of control through an app, so it performs different computations or actions depending on whether or not a programmer's specified condition evaluates to true or false. An example of a conditional statement supported by Java is the if-else statement, which helps apps achieve flexible flows of control through their algorithms and data structures. Another type of control abstraction supported by Java is iteration, which enables the repetition of a block containing one or more statements within an app. Examples of iteration features supported by Java include for loops, while loops, and do-while loops. These iteration features are often combined with conditional statements to write Java apps with sophisticated control flows. Yet another form of flow control abstraction supported by Java is exception handling, which separates the control flow paths of normal app execution from the control flow paths of anomalous app execution. For example, by using exception handling, the control flow path of an app will differ in a nicely structured way if the file it attempts to open is available on the computer versus not being found. When used properly, exception handling makes Java apps more robust and easier to understand and evolve. Now that you've completed the first part of this lesson, you should know what the concepts abstraction, inheritance, and polymorphism generally mean in the context of object-oriented programming, understand specifically how the concept of abstraction relates to the Java programming language, recognize the benefits abstraction provides developers of Java apps and Android, and be able to identify Java features that implement various data and control abstractions, such as Java's conditional statements, loops, classes, and interfaces. The next part of this lesson provides further coverage of inheritance and polymorphism, which are more advanced object-oriented concepts supported by Java.